Hello, in this video let's look at two examples of working with trigonometric functions. So here's the first one, sine inverse of square root of 3 over 2. So when we look at a setup like this, one of the ways is to look on the inside and ask ourselves which angle would we have to use in order for the sine to be square root of 3 over 2. And what that says is basically here is our unit circle, and the vertical side is sine, the horizontal axis is cosine. So the question is, which angle would give us the sine of square root of 3 over 2? So almost 1. And there is two ways to get to it. From this angle, from this corner, and that's 60 degrees. And then the same height can be achieved from the other side, which is 60 degrees shy of 180. Which is 120. So both angle 60 degrees and the angle of 120 degrees would produce the same length, square root of 3 over 2. The next question says, well, what is the sine of such angle? Well, the sine of such angle is asking what is the length of the vertical piece that corresponds with it. Well, we know that that's a 0.866 or square root of 3 over 2. So we get exactly the same answer as what the inside of our function is, which shows that the sine and sine inverse cancel each other off and give you just what's the inside. So that's all there is. We could also do that with a calculator and see if we get the same decimal, that 0.866, which is square root of 3 over 2. So for ourselves, we always remember that square root of 3 over 2 is 0.866. So when we run into that, we know that's what it is. So let's type in the sine inverse of square root of 3 over 2 and see if we actually get the decimal that we're expecting. And we do. So that confirms that our answer, square root of 3 over 2, is correct. Now let's look at the next example. Here we have almost the same setup. We have the cosine of cosine inverse 3 over 2. And so we might say, all right, the cosine and cosine inverse would cancel each other off, and I should get 3 over 2. And that would have been fine, except there is one huge problem. We are using unit circle to do all the computations. And so the question is really says, here is my unit circle, and the vertical axis once again is called the sine, the horizontal is called the cosine, but the radius is 1. So the most this length could ever be on any part of this circle is plus 1 or minus 1. And 3 over 2 happens to be 1.5, which is more than 1. So the question is saying, how many degrees do I have to rotate around this circle so that I get my length for the cosine to be more than 1, to be 1.5. So how many degrees do I run around this circle, unit circle, until I get to 1.5? And that'll never happen. It cannot be, because the circle at most has radius 1. So this is impossible. There is no such thing. There is no solution, or we can say this question is undefined. Now that brings us to a very important point, that for all of the inverse sine and the inverse cosine, for both of them, the inside has to be between -1 and 1. As soon as it is anything other than those coordinates, we will get into trouble, because that would not be possible. If it is less than -2, if the inside is less than -1, or more than +1, that would be impossible. So let's look at the calculator and see if that makes sense. So we'll type in cosine inverse of 3 divided by 2, and let's see if it gives us 3 over 2 or something else. So here's the answer, error domain. That means that we're trying to put in something into this cosine inverse function that is not allowed, that is not valid. So the calculator says the same exact answer that we have, no solution. And that's it for these examples. And if you have any questions on anything, please let me know. Thanks for your time. Take care.